For the second piece here, into box 2, we're looking at local maximums, local minimums, and zeros. So we're going to start by defining each of these three and then naming the examples of them for this function. So local maximums refer to the highest points in a given area. So local does not mean absolute. So we're not looking for the highest point overall, we're looking for the highest point in a given area. So as I look at this function, as I move from left to right, I notice there's a bit of a hump right here. So there's a point right here that is higher than kind of all of the surrounding points around it. So this red dot shows one of our local maximums. Moving along, again, right over here, we find another red dot that is the highest in the surrounding area. So that we would call this a local max as well. And then similarly, local minimums would be the lowest points in a given area, or the lowest points of some surrounding points. So those two have been labeled here. There are just two of them. Notice this arrow here on the left is not a local minimum. These arrows tell us that our function is going on forever. So it's going to keep going on forever down in this direction. So there is no local minimum happening there. The only local minimums are in these two spots. Real zeros are the points where it crosses the x-axis. So they're where the graph crosses the x-axis. So we have quite a few here. Notice as I move from left to right, we cross the x-axis right here at like negative 4.20. Keep going across the x-axis again, negative 20. Keep following along, cross the x-axis again at 1, 0. We've got a couple more that I've listed, 3, 0 and 4.70. So it's important to note real zeros as opposed to imaginary zeros are where the graph crosses the x-axis. So you can have imaginary zeros, but which means that if you plug those numbers into your function, it's going to equal 0, but those numbers don't show up on the on the graph because they would have to be imaginary numbers. So take a minute, make sure you have these definitions down as well as these points so you can use them as reference points. Next we have domain and range. So there aren't many other things we're going to be looking at here. This is really the last key concept for this target, domain and range. So domain refers to all possible inputs or x values. It's everything you can plug in for x in a function. Range is everything that you get out. So there are all of your possible outputs. So if I take every possible x value and plug it in, everything that I get out, that's my range. Those are my possible y values. So what we're going to do here is identify the domain and range for 4 different graphs. So I will do a couple with you, and then I'm going to want you to try a couple on your own to make sure that we've got this down. So remember, domain is all possible x values. So what I want to look for here with this graph is I want to look along the x-axis, and I want to see, are there any x values that I cannot plug in, that don't work? So as I look along here, starting from left to right, I notice an arrow here, meaning this graph is going to go down and to the left towards negative infinity. So that means every single x value to the left of it is okay. We can plug that in. It exists. It's going to show up on the graph. If I made this graph bigger and showed it, every x value to the left is possible. And I keep following along. These green dots are just points. They're not holes or anything in the graph. Keep following. All of our x values are good, meaning everything along the x-axis is cool. And we've got the same deal on the right. We've got an arrow moving up and to the right towards infinity, which means if I plug in anything on the right side towards infinity, it's all going to work. It's all going to be okay. So that means my domain is from negative infinity to positive infinity. And the way we write that is negative infinity is less than x, which is less than infinity, meaning x is between both negative and positive infinity. We can plug in any x between negative and positive infinity, meaning all real numbers, and we will get, and it works. It's okay. For range, we're looking at y values. So we're looking at what y values exist on this graph. So we're looking along the y-axis. So I start left to right. So I notice this function goes on towards negative infinity going down along the y-axis. And then we're going to come up along the y-axis, and we're going to hit all of these values here. And then we're going to move towards positive infinity here. Because it goes on, it's going to keep going up. So notice our graph goes both below 0 all the way down and above 0 all the way up, and it includes 0. It includes every possible y value. So in the same way, just like we have x is between negative and positive infinity, we say p of x is between negative and positive infinity, meaning our function along the y-axis, our outputs, can be any value between negative and positive infinity. So for this one, now we have an even function because it's moving towards positive infinity in both directions. Both are going up. So it's going to be a little bit different. So for our domain, we're looking at all possible x values along the x-axis. So we're going to start from negative infinity. Notice the left side has an arrow going up and to the left, meaning this function is going to go on towards negative infinity forever. So from negative infinity over to 0, we're good. We keep following. All the x values between 0 and 1 are good. Keep following. And then we have another arrow moving to the right all the way over. So we know our domain is going to be the same. It's going to be from negative infinity to positive infinity for our x values. The range, however, all possible y values is going to be different. Notice, because our function is even, it's moving up in both directions. This function will never have a y value of 0. Notice because it's moving up and because we don't see any y values of 0, it's not going to happen. This function isn't going to cross the x-axis. However, it's actually never going to go below 1. So it's going to go from 1 and it's going to go up towards infinity in both directions. So the way that we write that is p of x is greater than or equal to 1, meaning it hits 1. 1 is a possible y value, and then it goes up towards infinity. Domain's the same, as we said. Range is just a little different. All right, for this one, go ahead. Take a minute or two to determine the domain and range on your own, and then we'll talk through it. So, again, the domain is the same. It goes from negative infinity to positive infinity. There are no x values that are not possible. Same with the range. It goes from negative to positive infinity. There are no y values that won't work because it goes towards negative infinity on the left. It's going to go down forever, and on the right, it's going to go up forever. I do want to take a moment to note odd functions always have domain going from negative to positive infinity and range going from negative to positive infinity. It's important to note. However, even functions do not. It's a little bit different. So go ahead again. This one's a lot like number 2. Determine the domain and range for this function here on your own. And then we'll talk through it real quick. So again, domain is from negative infinity to positive infinity. All of our x values from negative over to positive are included. They're okay. Our y values, notice on the left side, this function goes down towards negative infinity along the y-axis. So everything below here is going to be included. So I'm looking at the y-axis here. As I follow this function, everything negative is good. I move up, I hit 0. I'm going back down to negative 4, up, I'm at 0 on the y-axis. I go up, I'm at 4 on the y-axis, and then I go back down forever. So nothing greater than 4 is possible. So we write that as p of x is between or greater than negative infinity, meaning it goes to negative infinity, and is less than or equal to 4, meaning it goes up to 4, it hits it, but it doesn't go any higher. Alright, for now, what I want you to do is go to the back side of your notes. There are 4 problems there. You're going to be answering a few different questions. So these are what they look like. You have to find end behavior, decide on the degree, odd or even, name the local maxima and minima. These are meaning how many maximum points are there, how many minimum, and you list them as points. So, like for example here, one of our local minima, meaning our local minimums, would be this point here. So you'd write the point negative 1.5, because that's our x value, and like negative 2.1. Doesn't got to be perfect, but that would represent this point here. Notice there's another local minima here, so you'd want to list that point as well. For the real zeros, you list your points too. So they've kind of been shown for you, but you want to write those. Then you list your domain and range like we have before. You're going to do that for 1, 2, 3, and 4 problems. When you are finished with that, check your work through Google Classroom. I will have the answer key posted on there along with the rest of the notes, so you can check your notes, check the answer key there. It'll be under the Notes tab. So I'll post the notes, which will include the front page, which we filled out together, as well as the classwork. So when you are finished, please check your work there. Please don't check your work before you do, or don't check the key before you do this. That's not going to help you learn this stuff. It's not going to help you practice. But you're welcome to check it as you go to make sure you've got it down. That's there for your use to make sure you've got this stuff down. So please use it wisely. When you're finished with that, please move on to the gallery walk. So up around the room, there are a few, or actually quite a few, different pictures of graphs that are asking you to answer a few different things. So what I want you to do is move on to that activity when you're finished with the classwork and get started on that. I hope the notes were helpful. Again, if you have questions, or always, not really again, but always if you have questions, I'm here to answer them. We'll talk about this when I see you next. So either tomorrow for A and B block or Thursday for my D block.